This is the land of the last redwoods, among the oldest living things on Earth, the largest and the tallest. Redwoods are a tribute to the majesty of nature and to the persistence of life. In prehistoric times, there were at least 30 kinds of sequoias. Today there are only 3. The Sequoia dendron giganteum, the giant sequoia, is one of the biggest living things in the world, and also one of the longest living. The Sequoia sempervirens, our coastal redwood, can grow up to 350 feet high and is one of the tallest trees in the world. Both of these species are found primarily in California. There are also a few specimens of the genus Metasequoia, a distant cousin of the California sequoias that was discovered in the 1940s in China. During the redwood's early days, 200 million years ago, the world's climate was much different than it is today. There were many places on the planet that were temperate and moist, where the large sequoias could thrive. At one time, ancestors of the sequoias were found in Asia, Europe, Greenland, Russia, even Alaska. As the Ice Age developed, the sequoias were forced south. At one time, Kansas and Arizona were moist and temperate, and redwoods flourished there. Today, the giant sequoia is found only in the California Sierra Nevada mountains. Coastal redwoods grow only along the Pacific Ocean, between Oregon and Big Sur. Redwood forests are actually temperate rainforests, and redwood trees need a climate that is cool and very moist. A mature redwood, for example, holds up to 800 gallons of water. The trees can't tolerate extreme cold or drought, and they need fog and heavy rains, a minimum of 30 inches each year. At the southern edge of their existence, Santa Cruz and Monterey counties, where the climate is drier than further north, the redwood trees are smaller and grow only in places that stay moist and cool throughout the year, in the coastal mountains, near streams and springs, and in small valleys like the San Lorenzo, where the fog likes to sit. But it is not only the redwood's incredible persistence over time that has earned them the name sempervirens, the ever-living. It is also the huge lifespan of individual trees. There are living redwoods that have been on this planet for more than 2,000 years. Giant sequoias can last twice that long. Mature redwoods can survive even serious forest fires. They don't contain large amounts of flammable pitch or resin like many other trees, and the large amounts of water they retain, along with their thick bark, help to protect them from fire. Redwood trees also contain a substance called phenolics that protect the trees against disease, termites and other insects, and rot. This is what makes redwood a good material for building decks and other outside structures, and what made them popular for shingles and siding at the turn of the century. A redwood can be weakened by fire or by heavy snowfall, but essentially nothing, except humans, can kill a redwood tree. Often, what causes the demise of a redwood is its mass. It literally becomes too heavy to be supported by its root system. And when high winds come, the tree is blown over. After the tree falls, it can take another 1,000 or more years to decay and decompose. Another miracle of redwood trees is that they are one of the few conifer species that will sprout from the stumps of trees that fall over or are cut down. The new trees will often grow in a circle, called a fairy ring, around the base of the mother tree. Baby trees can also spring from fallen logs or from burls. We are still learning about redwood trees and only recently have begun to look at the entire redwood forest ecosystem as habitat and as an integral system that plays a large part in our climate, in water filtration and watersheds. Because so many of the redwoods, especially in Santa Cruz County, have been cut and are second growth, we're starting to look at the way we manage what's called the secondary succession, so that the forests we hand down to future generations are healthy. And we're only starting to know about the value that old-growth redwoods play in the rainforest ecosystem. Scientists once thought that temperate redwood rainforests had little biodiversity, but they've recently discovered that up to 200,000 different kinds of mites, microscopic creatures, live in the duff layer, the layer of fallen twigs and needles on the forest floor. We are finding that redwood forests are much more diverse than we previously thought. Moving walls of mud, hillsides fallen away, rivers and streams choked with silt. These are familiar sights during the heavy winters that batter California's coast. Ours is an area prone to landslides. Many of the hillsides are steep. Earthquakes are common. The intensity of the rainfall here is as great as it is anywhere else in the state. The soils here are non-cohesive. They don't stay together and are easily eroded. Pockets of thick, unstable soils are common. Landslides and erosion are most likely to happen where there is a high intensity of water passing over exposed soil and when the soil is saturated with water. Some landsliding is inevitable. The movement of soil is a natural phenomenon, and a certain amount of erosion and landsliding is beneficial to the coastal ecosystem. Topsoil that is washed downstream can form fertile alluvial plains. Land and mudslides change the topography or shape of the land. This is one way of promoting biodiversity. Too much earth movement, however, can be devastating. Excess silt destroys habitat and kills life in rivers, streams, and estuaries, and where waterways enter the ocean. Topsoil is precious. Soil is Mother Earth. Life springs from the soil, and the soil nourishes living things. An inch of soil takes many hundreds of years to develop. It can be washed away in seconds.
What I'm standing on here was all these 6 check dams were filled up 8 to 10 feet deep with sediment in one evening. One evening in a January storm in 1982, all these check basins filled up, totaling 1,000 cubic yards.
What keeps the soil in place? The integrity of the hillside or mountain, and the vegetation and tree cover. Most human-caused landslides occur where we have destroyed the integrity of a slope by cutting into it, usually for a road, or by concentrating the flow of the runoff. Further undermining happens when natural channels for water infiltration and storm runoff are blocked, where culverts fail, where asphalt and concrete have covered the soil so that rainwater no longer soaks into the ground but collects and runs off with great force. In any ecological system, soil stability is a balance of natural forces. Along the California coast, one of the most important factors maintaining that balance is the natural tree cover and vegetation provided by the coastal redwood forests. Redwood trees play a direct part in keeping soils stable. The roots of the trees anchor and hold the soil. If a redwood tree is cut down, the roots remain alive, but the root system and its holding ability are seriously weakened. The redwood tree cover also decreases both the impact of water on the ground and the amount of storm runoff. The needles of the tree cushion the fall of the rain.
A tree growing in a watershed, particularly a mature tree like this giant redwood, will pump many tons of water a day out of the soil. So when you take this component of the watershed away, the weight of the soil increases. And we get, in this part of the country, in the Santa Cruz Mountains, we get a lot more landslides when the weight of the soil increases.
The tree holds water, releasing it slowly over time, decreasing the volume of the winter storm flows.
The water which falls as rain up here soaks into the ground, flows through the ground slowly, taking many years to reach Schehl Creek a half a mile away, and then feeds that stream with water throughout the year.
At the base of the tree are fallen needles, branches, and other decaying vegetation called the duff layer. The duff layer also acts like a cushion to protect the soil from being detached by the impact of falling raindrops or washed away by the force of the water flow. The roots of all vegetation help hold the soil. Redwood trees indirectly assist this process by protecting the native understory vegetation. During the summers, the redwood trees capture or intercept moisture from coastal fog, and the water that drips from the needles of the trees, called fog drip, supplies the understory vegetation with as much as 75% of the water it needs to stay alive during the dry season.
The most amazing thing about the redwood forest is probably the soil and the soil organisms below the trees. 1 teaspoonful of soil in a redwood or a Douglas fir forest can have over 60 miles of fungal hyphae. Okay, these small mushroom hyphae connecting not only mushrooms to trees, but even trees to trees, so that nutrients actually can pass from one tree to another tree. And these fungal hyphae are what allow the trees to live. Without these fungi, the trees themselves would not survive. And this is all fairly recent work. Mycorrhizal fungi is what it's called, and it's crucial to the life of the forest.
The balance of nature relies on interdependent systems and living things working together. One of the most graphic examples of this interdependence is the relationship between redwood trees and the topsoil in which they grow. For not only is the stability of the soil dependent upon the vegetation that grows in the redwood forest, the trees, too, need the soil to survive. In order to develop fully, redwoods require a soil layer that is several feet deep. The trees cannot grow in soils that are rocky or too shallow. Logging that happened during the last century has caused erosion that has already removed much of the soil from the redwood forest. In many places, the trees are growing in soils of marginal depth. We need to protect the soils that remain by keeping the tree cover and vegetation, maintaining roads and culverts, not cutting into hillsides, and allowing the natural infiltration of the water into the soil. Fire is a natural and integral part of the coastal redwood ecosystem. We can tell by scars on the rings of dead trees that here on the Central Coast, fire has occurred in our redwood forests about once every 30 years. In the damp, cold area near rivers and creeks, fire may occur only once in every 100 years. Today, most of the fires that occur are caused by humans, but those that are naturally caused are a result of lightning. George Gray is a resource ecologist for the California State Parks Department.
The first fires in redwood ecosystems were started by lightning. And present records show that every 20 to 30 years a fire starts in southern Santa Cruz County and lights the countryside on fire. And they don't stop. We stop them, but naturally they would burn maybe the entirety of Santa Cruz County.
One purpose of a fire in a redwood forest is fuel reduction. Fire clears out debris, dead branches, fallen needles, overgrown bushes, and some of the young trees that may otherwise compete with other trees for space and nutrients in the forest. This is known as a stand maintenance fire. A stand maintenance fire not only clears out the debris in a forest, it promotes natural biodiversity and reproduction. Certain plant species, like the ceanothus, need fire. Its seeds can only sprout after they have been scarified or scarred and cracked by high heat. The seeds of these plants can lie dormant in the ground for 50 to 100 years, waiting for a fire. Most redwood trees can tolerate even frequent, hot, stand maintenance fires. The fire will scar the tree and can kill or maim lower branches, but the top or crown of the tree will continue living. Repeated fires can cause hollow places at the bases of the trees.
For this particular tree, what probably happened was that a small fire scar maybe might have started, which might have looked like that, and then the next fire, which burned in, made the hole bigger. And the years in between, the fire would grow around the scar and create the bigger hole. And then the next year, the fire would burn in farther inside the tree. The fire would get larger. until sometimes you get, they used to call these goose pens because people would put geese in them overnight to protect them from predators.
But even the redwood trees will be killed if the fire is too big or too hot, which can happen if too much fuel, dead branches, and understory bushes are left on the ground. Large fires can travel up the trunks of the tree and become what is known as a crown fire that can kill everything in the forest. This is known as a stand replacement fire. Humans have been altering the natural fire patterns for thousands of years. Nearly 3,000 years ago, the Native Americans who lived here regularly set fires. These fires could burn for weeks at a time and cover entire portions of the San Francisco Bay Area.
Native Americans were in great numbers comparably around the coast of Santa Cruz County. They would light fires on the coast. They would burn inland with onshore winds. And they increased the fire frequency. When you add them all together, these trees for thousands and thousands of years have gotten used to fires of every 30 to 100 years, depending on where the tree lives.
In the late 1800s, most of the forests in the area were clear-cut, and the loggers left huge piles of debris called slash. Because of this logging, massive wildfires swept the area between 1860 and 1920. Today, though, we have almost wiped out forest fires.
CDF is one of the best agencies for putting out fires in the world. And they've done a very good job in the last 50, 60, 70 years in putting out fires in this kind of ecosystem.
This has saved many thousands of acres of forest, many homes, and many lives. But controlling fire has also created a problem. Without regular stand maintenance fires, the brush and debris builds up on the forest floor.
And we found through our studies that approximately 1 ton per acre per year builds up in redwood ecosystems. And that's an enormous amount of fuel. When you take the 50,000 acres in Santa Cruz County in state parks, that's 50,000 tons per year that's built up.
In many areas of the state where fire has been suppressed, fuels and debris have built up so much that scientists fear there will be devastating stand replacement fires.
There's several components to this fuel in the forest. The most obvious is the leaves and bark pieces laying on the ground. That's called a litter. Underneath that is this litter in various states of decomposition. And it can be up to 2 feet thick in areas which haven't burned for a number of years, and that's called duff underneath your litter. And then there are various sizes of fuels up above which add to the ferocity of a fire. One would be small sticks. They're called 10-hour fuels because it takes 10 hours for them to adjust their moisture content. And then the larger ones are 100. In the background you see probably 1,000-hour fuels. Usually your 1,000-hour fuels don't burn in a large wildfire. It's usually the smaller pieces that contribute to a fire, and the big logs will be left. That might you might relate that to the logging industry, which comes in and removes only the big logs from your ecosystem and takes the 1,000-hour fuel and leaves your sticks and needles and limbs. And these are the things that are left there as slash, which contribute to a fire. And this builds up over the years.
Many areas are due for a huge stand replacement fire. Ours is an urban area, and many homes are nestled among the redwood trees. The prospect of a serious fire here is alarming. To avoid catastrophic stand replacement fires, different measures are being taken. In some areas, the debris and slash are being removed, but this is not a practical solution on steep slopes or in remote or inaccessible places. And so, controlled burning is being introduced in forests throughout the world.
The state parks, recognizing this, began a program 20 years ago to light prescribed fires. Big Basin Redwood State Park, about 10% of the park that we do want to burn has already been burned. We burn 300-acre plots. They take about 10 days every year, and the goal is to reintroduce fire to its natural role in the ecosystem. 2 other things that a fire does to maintain the stand a healthy stand of redwood trees is to remove the ladder fuels. There's rungs of a ladder which leads a fire up into the top of trees. And in the background you can see various small shrubs, medium shrubs, and larger trees which lead up to redwood trees. And a fire will remove one or two of the rungs of that ladder so the fire can't get to the top. In addition to that, the fire will raise the canopy on some of these trees without even killing them. And by that we mean it kills the lower limbs, and that removes this rung of fuel which might lead to the canopy.
Some people maintain that logging should be used instead of fire to thin the forest and remove competing trees.
There's some discussion about prescribed burning versus logging or mechanically thinning out trees. It depends on what your objectives are. If your objective is for some economic benefit from the trees or the use of the resource for human use, then logging is one alternative. If your objective is to have a naturally functioning ecosystem and a museum piece out there of what California used to be, then prescribed burning is your preferred alternative. You get erosion after both. Normally after a prescribed burn or a wildfire you get a spike of more sediment that comes off because you remove that blanket which covers the soil. You also get that from the mechanical disturbance and the dragging from the logging. But a number of studies have shown that because of the skid roads in the road building and the soil disturbance, that your spike of sediment goes on more years during a logging operation than it would during a prescribed fire.
We are still learning how the redwood ecosystem functions, and our knowledge about the role that fire plays has only recently begun to be understood.
One of the things that we have to look at throughout the years is what is going to be the most sustainable process in order to maintain an ecosystem. And we feel that the reduced use of fossil fuels from prescribed burn operation and reduced damage to the soils from the limited amount of entry into the area is the best to maintain these areas forever.
Water is one of our most precious resources. Without it, there would be no life on Earth. Humans are dependent upon the watersheds that carry and store our water, and so are the creatures that live along the Central Coast. Don Alley is a fisheries biologist who studies and monitors local steelhead populations.
But in fact, 90% of the animals that live in the forest use the riparian corridor. It's critical for their survival, their life history. So that's the area that's most important to protect.
A properly functioning watershed performs many functions: storing water, shedding water, purifying water, maintaining climate, providing habitat and food. The trees in our redwood forests are vital to watershed health. The streams and rivers of the watershed shed or carry rainwater, and because trees, vegetation, and soil absorb water and release it slowly over time, they work to lessen the winter storm flows and to keep water flowing all year round.
Because that's really the job of a watershed. Rather than shedding its water, it's retaining its water and keeping it in the ground, and so it'll be released slowly. And that's particularly important in our watershed here because we live in a Mediterranean climate where it doesn't rain for some 6 months of the year, sometimes longer. And so the streams flow in the summer from groundwater that comes into the stream slowly. So the more water that's retained in the winter in the ground, the more stream flow you'll have in the summer. And that's very important to steelhead.
In a redwood forest, the trees intercept water and recycle it into the air.
A fully functioning forest pumps many tens to many hundreds of tons of water per acre per day out of the soil. And that water is evapotranspired back into the atmosphere.
The mature trees that live in the riparian area play a vital part in the functioning of a watershed.
And it's the trees that provide the shade of the streams and keeps the water temperature as low as possible. And that's very important for steelhead and coho salmon. They have an upper temperature tolerance above which they just can't survive.
The roots of the trees also anchor the soil, stabilizing stream banks and lessening erosion and sliding.
As you can see here, during winter flow, the stream comes up quite high here, and the only thing that's holding these banks in place are really the trees. We have this clump of trees right here holding this bank. If we look down this way, we have redwoods holding that bank up. If you look across the way, we have a Doug fir over here, a large one holding that bank, another Doug fir, redwood, Doug fir. This forest has many species of trees. It's a redwood forest, but it has many species. So we need these trees here to actually hold the stream banks so that we won't get sediment coming into the streams, so the stream banks do not erode.
The needles that fall from the redwood trees decompose and become food for insect larvae. In turn, these insects and larvae are food for the fish.
We need to realize that in a watershed we have a whole system. The terrestrial system interacts with the aquatic system. They're not separate and distinct. If you're going to manage the stream, you also have to manage the forest next to the stream. And it's particularly important when you think about what the fish eat, their food. In these very shaded streams, there aren't very many insects that are actually produced in the stream. Those that are larval insects that live primarily in riffles, which is this whitewater area that we see running into the pool. So fish will live in the riffles, but they'll also feed at the heads of pools as the insects drift down into them. But also probably a more important source of food for the fish in these very shaded areas where you don't get much production right in the stream is actually insects falling off of branches from bushes and trees. And that's another reason why you need to make sure you protect the vegetation along the creeks, particularly the overhanging vegetation. An adult insect could be blown off of a leaf and fall into the stream, and the fish are very adept at catching those insects. So in these very shaded areas, a major part of their diet may be the insects that fall from the trees into the stream.
And when a tree falls into a stream, the decomposing wood, too, becomes food for these creatures. Tree branches and dead trees, called woody debris, also form habitat for many creatures.
Right in front of us here, we have some woody debris in the channel. Now this woody debris does a couple of things. Once it reaches the channel, it actually forms a scour object that scours out areas and creates pools. And when stream flow gets very low in the summer, many of the fish survive in the pools where it's deeper, and then they can also hide under the woody debris. Right here is a pool where coho salmon or steelhead would survive in the summertime. You have a riffle coming in and then a log that is collected here in the pool area. And usually woody debris does accumulate in pools. So this log provides cover underneath it, as well as creates some turbulence right at the head of the pool to help scour out the pool. Of course, we also have the bedrock over here, which is also a scour object. So it's very important to leave things like this woody debris in the pool. And then we look downstream here, and we see more woody debris. And there's a large log that will eventually come into the channel, but even so, it has created an area which collected other woody debris. And that's often what happens. The larger woody debris will collect smaller woody debris, kind of like a sieve, so that some of the woody debris stays in the upper watershed. It doesn't all go down at once. And it can decompose there, add nutrients back to the stream. But also the woody debris collects sediment. And you can see some sediment that's collected there as well. Now that's very important because if we had all the sediment from the upper watershed dumping into the main stem at one time, then the main stem would just be devastated with sediment. All the pools would fill up, the spawning gravels would be smothered where the steelhead spawn. These woody debris jams keep the sediment from reaching the main stem all at once. So it also sieves out the sediment. And you can see that very easily right here.
The large rivers within our county carry woody debris to the ocean. Big logs play an important role both on shore and at sea.
In the old days, when the large woody debris would float out into the ocean, it would be kind of like a raft. And you'd have these huge trees floating around in the ocean with the currents. And then there were specific fish that would collect underneath these large pieces of woody debris. So the wood would become cover for the fish in the ocean, as well as its cover in the freshwater systems as well.
Many areas are starting to restrict logging within the riparian area to maintain these vital watershed functions.
So what I think should occur on state land, as does occur on federal land, you just set up no-cut, no-entry buffer zones along all the creeks, and even the ephemeral creeks. As you can see across the channel here, we have a small tributary coming into Fall Creek. So these no-cut, no-entry buffer zones would also protect those smaller tributaries, even if they dry up in the summer. We found that most of the erosion in the watershed happens along second and third class stream courses that may not flow during the summer, but in the winter they definitely flow. So you need to protect the margins of those channels as well as the main channels that have the fish in them.
Santa Cruz County is currently the only county within the state that supplies all of its residents with drinking water derived completely from local sources. 90% of the birds and animals here rely upon the riparian area for their survival. Counting the tributaries that feed these rivers and streams, virtually all of the county is within a watershed. What this means is that we all must be watershed stewards and recognize that the value of our redwood forests in maintaining the creatures that live here and the quality of life for all of us. That value is far greater than short-term economic gain. It is the value of beauty, the value of abundance, the value of life. Old-growth redwood trees are among the oldest living beings on Earth. Their history we can only guess. Their value we are just beginning to understand. A redwood tree becomes an old-growth tree not necessarily when it grows big, but when it attains certain characteristics that come with age. The crown, that includes the green part of a tree, in an old-growth tree is rounded instead of pointed, like redwoods are when they're young. The branches may be irregular and misshapen, and there may be no branches at all on the lower part of the trunk. An old-growth redwood tree has bark that can be up to 2 feet thick. There may be scars on the tree from injury or fire, and knots and burls. In an old-growth forest, the trees are different sizes and different ages. This is one thing that helps to increase biodiversity by creating habitat for numerous different species. Scientists are only beginning to understand the functions and value of old growth. Until recently, many people thought old-growth trees, especially those with flaws or rot, were essentially worthless and should be cut down to make room for new, young trees. But we're starting to change the way we're thinking, and one of the things that fostered this change is concern for endangered species, such as the spotted owl, that can only live in old-growth trees. Although the spotted owl is not found south of San Francisco Bay Area, here in Santa Cruz County, the endangered marbled murrelet, only nests in old-growth trees. Murrelets need a large horizontal branch with a flat platform where the bird can build a nest. There must be cover to protect the nest and to hide it from predators. These characteristics are only found in old-growth trees. The thick bark, cavities, and irregularities of old-growth redwood trees are habitat for mosses, fungi, insects, birds, and animals. Most old-growth redwood trees have survived repeated fires. The fire destroys lower branches of the tree and can damage the tree trunk, forming open spaces called goose pens. Bats use these goose pens for daytime roosts. Unlike other trees, which can die from injury, disease, or fire, redwoods seldom die standing and usually don't form standing dead tree snags like other old trees do when they die. More likely, a living redwood tree will become too big to be supported by its shallow root system, and the wind will blow it over. When the tree falls, the roots pull out of the soil, creating pits and mounds of earth. This uneven pit and mound topography provides places where water can collect, places where small animals can live. Thus, even as it dies, the redwood tree performs an important function in the forest by creating habitat and biodiversity. A fallen redwood tree can take up to 1,000 years to decompose. As it does, it returns nutrients to the soil. Creatures such as salamanders make their homes underneath fallen trees. Chipmunks, mice, and other rodents during forest fires can hide in hollowed redwood logs or burrow underneath the ground beneath the logs to escape the flames. After the fire, these animals will defecate seeds and fertilizer that will help the forest regrow. An old-growth forest is an interaction of numerous different species, forming a complex system that has evolved over thousands of years. In the past, we took wantonly from our redwood forests. We manipulated the forests, assuming that we could improve on nature's design. And now we know we were wrong. We are starting to realize how complex the redwood forest is and to understand the intricate interworkings within the forest. The habitat, climate, and even quality of life along California's coast are greatly influenced by the health of our redwood forests. We have the power to preserve and to foster the health of our forests and of Mother Earth. In the words of environmental consultant and mediator Chris Mazer,
but I had become concerned about two things. And that is that in every environmental conflict I've dealt with, whatever country it's been in, I've found two silent voices. The first is the children's, and the second is the land's productive capacity. If those are not taken care of in resolving a conflict, then we are not being equitable, we're not being fair, we're not being just to the next generation. And understand, they must live here. They have no place else to go. There are no more hills to conquer, no more continents to find. The other thing is that our choices become their circumstances. In that, they don't have a choice. The only choice they might have is how they respond to the circumstances we leave them.